We're going to work through a really tough logic game from LSAT 62. Many consider this to be one of the toughest logic games of all time. I'm going to show you it really doesn't have to be that tough if you do it the right way. So if you have test 62, you should open up to section 3, questions 7 through 13, and follow along. So we have an artisan creating 3 stained glass windows, and we're using 5 colors of glass, G, O, P, R, and Y. As usual, we're going to write out what the elements are at the beginning of the game. We're going to write out the first letter of each one, just for simplicity. And each color of glass has to be used at least once, and each of the 3 windows has to have at least 2 colors in it. So we're assigning colors to windows, so it sounds like it's a grouping game, right? We have 3 windows. We'll call them window 1, window 2, window 3. This is the standard setup for any grouping game, right? We just have the 3 groups here, and we're just going to be assigning the colors into the windows. And if you look at question number 7, that's a good hint, right? That seems to be the way that they're setting this up. They're assigning colors to windows, and the windows are the groups. Now, we need to look at the parameters. We always need to look at parameters for grouping games. So each color of glass will be used at least once. So these, of the elements, there's going to be at least one plus of each. And what about in the groups? Are there minimums or maximums? The answer is yes. Each window, it says, will contain 2 or more colors in it. And so therefore, there's going to be 2 plus in each group. And so we're going to write that right above the groups. Let's take a look at the rules. So the first rule tells us that G and P are going to go together exactly once. So we don't know what group that's going to happen in. So I'm going to write it to the side of the groups. I'm going to write it over here. I can't write it underneath group 1 or group 2 because I don't know which group it's going to be in. This is how you show that 2 letters go together. Put them in a vertical box like that. And I'm just going to write once. It has to happen precisely once. Second rule tells us that there's going to be 2 R's. So very simple. Again, I don't know which group, so I'm going to write it off to the side, but I'm going to make note that there has to be 2 roses. The next rule is conditional. If any given window has Y, then it cannot have G or O. So if Y, we always show conditional rules with an arrow. So if Y, then not G, and also not O. Now, the truth is that this rule could be simplified. Conditional rules tend to be a little bit tricky to work with. And so a rule like this, really all it's telling you is that Y can never go in the same group as G, and that Y can never go in the same group as O, right? Because if you have Y, you can't have G. That's another way of saying that those 2 letters can't go together. Same thing goes for Y and O. And so I'm going to show you that a much simpler way of writing this rule, instead of doing it like this, just write that Y and G are not compatible with one another, and that Y and O are not compatible with one another, and that will make this game much simpler. Final rule says that if you don't have purple, so again, we'll write it the way that it's written on the page as a conditional rule. If it doesn't have purple, then it does have orange. Now, let's think about what that means. If a group doesn't have purple, then it does have orange, which means it's another way of saying that it always has to have either purple or orange, right? Because if it doesn't have one, it has to have the other. Every single group, according to this last rule, is always going to have either purple or orange. So that's going to be something to think about going forward. We'll leave it as is in terms of how it's written on the page, but that's essentially what that rule means, is that every single group, if it doesn't have purple, it must have orange, which means it always, for all 3 groups, must contain purple or orange, or perhaps both. So this is our setup. I'm going to box it off, and let's go towards the questions. Number 7 is a standard acceptability question, just like the first question usually is on these logic games. So what we're going to do is we're going to test out the rules. We have 4 rules here, and instead of going A, B, C, D, E, we're going to go rule 1, and we're going to check all the answer choices for rule 1. So I'm going to write A, B, C, D, E on the page so we can keep track of what we're crossing out. So let's look for any of the ones that break rule 1, which is that G and P have to go together once. So in A, that looks fine because G and P go together once in window 1, and they're not together in any other window. In B, we have G and P, once again, going together once. C is a problem, though. C, we have G and P together in window 1 and in window 2, and so therefore C is going to break that rule. D is good, and E is good. They both have G and P together once. Next rule, there must be 2 roses. So we're going to skip C this time. We're just going to do A, B, D, and E. A, we need 2 roses. We're good. We have a rose in 1 and a rose in 2. B, again, we have 2 roses, so we're good. D, we have 2 roses, so we're good. E, we only have 1 rose, so E breaks that rule. Next, Y can never go with G or with O. So A, Y does not go with either one of those, so that's good. B, once again, is good. Y doesn't go with either of those colors. D, we have Y going with O in window 2, and so therefore D is a problem. We're going to cross it off. Final rule, every group has to have either P or O. A, window 2 does not have P or O, and so that is a problem. And so therefore the answer is going to be B. Let's move on to number 8. Which of the following cannot be one of the windows? Now, since we're early enough on in the game, we should sort of look for a shortcut here, right? The first couple questions are usually pretty simple, and we know that every window has to have either purple or orange. That seems like a simple thing to look for, and lo and behold, if you look at all 5 of these answer choices, just skim them for that rule, they all have either orange or purple in them, except for C. So that's a very quick way to find the answer here, that number 8, there's nothing really to test out. If we wanted to, we could test each of these out. We could draw out a scenario with A, where green and orange is one of the windows, and see if it works, and we would see that it does work. Do the same thing for B, do the same thing for C, and we would say, whoops, C doesn't work. But that's a quick shortcut. If you know the simple implications of the rules, you can see very quickly that C doesn't have either purple or orange in it, and so therefore it is the answer. It can never be the complete combination of the glass in one of the windows. Let's move on, therefore, to number 9. So 8 we said was C. Number 9. If 2 of the windows have 2 colors each. So normally when there's an if in the question, we would draw out the if. We would make it true. However, this is too vague. There's no one specific way to make this true. There's too many ways to have 2 of the windows have 2 colors. And so therefore, I'm just going to write this out as a rule that only applies for this question. It's sort of like we already have 4 rules, and this is rule number 5 that only applies for this question. We have 2 windows to have 2. I'm just going to write that on top of this question to remind myself that 2 of these windows have to have exactly 2. And we're just going to go test out the answer choices, because normally we would start off plan A by making the if true and seeing if that gets us the answer. In this case, it's not enough. And so therefore, we're going to plan B, which is to test out the answer choices. And since they're asking us which of the following could be true, the way to test out that is to try to make each one true and see one of them should work and 4 of them should not work. And so therefore, let's try A, put rows in yellow in one of the windows. It doesn't matter which window we put them in, because you may have noticed all 3 windows are identical in terms of the way they're treated by the rules. And so therefore, if RY works in group 1, it should also work in group 2 or group 3 as well. Now, you may notice right away that this is not going to work right off the bat, because if that's the complete window, that breaks this final rule. Once again, this rule being simple really makes this game much quicker for us. It doesn't have P or O in it. Every window needs P or O in it, and so therefore that's not the answer. Let's go on to B and see if O and R could be one of the windows. Now let's see if that's the complete combination of one of the windows. I'm going to put a little scribble underneath to remind myself not to put any more colors into that window, because they're telling me that's the complete combination of one of the windows. So let's see, what else do I need? I know that I need GP in at least one of the other windows. I'm just glancing through the rules, that's just the first one that I saw. I know I need GP, right? I know that I also need to have 2 roses. So I already have 1 rose over here. So let's go ahead and put the other rows in this last window. I know I need to have a Y somewhere. If you look at all of these, you have G, O, P, and R, but we never used Y. That's the 5th letter. And so therefore, Y can never go with G. And so therefore, Y can't go in group 2, would have to go therefore in group 3. And group 3 is the only group now that doesn't have a P or an O. I'm just looking through all these rules. We've followed all these rules so far except for this one. This last group needs either a P or an O in order to be kosher, but O can never go with Y, and so therefore it would have to be a P. But it looks like now we followed all the rules. B works, and so therefore B is the answer. No reason to test out any of the other ones. We found that B definitively could be true. Let's move on to number 10. If one of the windows is PRO, again, complete. So they gave me an if. I'm making the if true. That's always how you start the question. Make the if true whenever possible. One of the windows completely is PRO. Let's see what else we can figure out. So we know that, again, we always know that there's another window that has GP. It doesn't matter whether I put it in 2 or 3. It's going to essentially work out to be the same thing, because the windows are all identical, as we've stated previously. So therefore, let's go ahead and put GP in window 2. Now, what are we missing? We have G, O, P, and R. Once again, we're missing Y, which is common because Y is the most difficult letter to place. It has issues about who it can go with. And as you can see, Y could not go with G and P, because Y can't go with G. And so therefore, Y must go in this last window. By the way, you may now notice that Y always has to bring P along with it because Y also can never go with O, and every window needs to have either O or P. And so if Y is not going with O, Y better be going with P. And so you can already see that we can already figure out if one of the windows is P or O, the other two windows are going to have at least those letters as we have written. So we've used all the letters G, O, P, R, Y. We have taken care of this rule, this last rule. Every window has either P or O. We haven't messed up Y, so we've taken care of this rule so far. We've taken care of the first rule. We just need to make sure that there's another rows to go somewhere. The rows can go either in window 2 or 3, but other than that, we're pretty much good to go on this setup. So let's take a look at the answer choices. The complete combination of glass in one of the other windows, so either groups 2 or 3, could be what? So could it be GOR? That's A. No, neither one of these windows could be GOR because they both have P in them. B, could it be GOP? The answer actually is yes, because window 2 has a G and a P. The R could just go over here instead of over there, and I could just throw in an O. There's no reason an O cannot go in that group, right? There's nothing that O doesn't get along with. O can't go with Y, but Y is not in that group. So I could just throw in an extra O. There's no limit to the O's, and so therefore I could make B true, and so therefore that's the answer. The other ones don't work. If you look at groups 2 and 3, none of them are compatible with C, D, or E. Let's move on to number 11. I'm going to do it over here. Number 11. If orange is used more often than green, so if there's more O's than greens, than G's. Now again, they gave us an if. Let's see what we can figure out before we look at the answer choices. So what does that mean if there's more O's than G's? Think about it for a second. There have to be at least one of each of the letters. And so if there has to be at least one G, that would mean that there would have to be minimum 2 O's, right? So there has to be either 2 O's or 3 O's. Could there ever be 3 O's though? Let's try to narrow that down. What do you know about O from looking at the rules? You know that O cannot go with Y, and so therefore it's impossible for there to be 3 O's because then there would have to be no Y's. And so therefore we've just narrowed down that there have to be therefore 2 O's and 1 G. That must be how these are laid out. And let's go ahead and start plotting those down. There's 2 O's. Now the G doesn't necessarily have to be in the third group. It could go along with one of the O's. It's just that there are more O's than G's. So I'm not going to place the G quite yet. But I do know there are 2 O's. And I know that Y never goes with O. I'm just looking at the rules that deal with O because that's the letter on the page. And this is telling me that Y doesn't go with O. So therefore Y would have to go in the third group and the third group only. And I know that each of the letters is used at least once. So therefore Y can only go in group 3 and must go therefore in group 3. And Y would have to therefore go with purple because every group has to have either purple or orange. Now I need 2 R's. The 2 R's seems like they could go in a couple different places, but the GP, remember, G can never go with Y. And so since there's a Y already in group 3, the GP would have to go in either group 1 or group 2. Let's just go ahead and put it in one of these. So as of now, we've taken care of this first rule. We've taken care of this last rule. There's a P or an O in every group. We haven't messed up Y, so we've taken care of this third rule. So the only thing we need to worry about is placing 2 roses, right? Let's take a look at the answer choices because we have everything pretty much laid out on the page. One of the windows could be A. Could one of the windows be orange and purple? Well, the only one of these possibly that could be orange and purple is maybe this first one. I'll put a small p here to test it out, and then the 2 roses would have to go in the other groups. That seems like that would work. We haven't violated anything, and so therefore A is the answer. Now, the reason I did that small is because if it didn't work, I would be able to cross that off and then go ahead and test out B and leave all the big letters on the page. But A worked, and so therefore we can move on to number 12. Which of the following could be in all 3 windows? Well, let's take a look at number 10. If you just look on the page and see if there's any letters that you've ever used in all 3 windows, there's not that many scenarios. So you could probably scan all these in a few seconds and see, wait a second, purple was in all 3 windows in number 10. And so therefore no need to even test that out. There's also obvious reasons why some of these other ones could never be in all 3 windows. Rose, we already know, is twice explicitly in one of the rules, right? Yellow has trouble going with green and O, and green and orange. And green and orange have trouble going with yellow. And so none of those letters could ever be in all 3 groups because that would preclude another letter. But that is unnecessary stuff to think about because, as you saw, the answer was already on the page. Let us, therefore, do the final question, number 13. You can see this game really is not so bad, right? Okay, so number 13. Number 13 says that none of the windows can have R and O. So let's go ahead and write that out. That means that R and O can never go together in a group. That's how we would show that. This is essentially giving us a rule that applies for this question, and this is the way to show that two letters cannot go with one another in a group. So what does that mean? Before we look at the answers, let's think about what we can infer from that. We know there always have to be two R's. We can put them in any two groups. But whatever group the two R's are in, since there has to be at least one of each letter, the O would have to go in the other group. We also know, as we've said several times, that every group has to have either a P or an O. And so since these first two groups aren't getting an O, they better both get a P. Sorry, I'm running out of space here. They better both get a P. What else do we know? We know, so we've taken care of this last rule. We've taken care of the two R's. So we have just these two rules to worry about, first and third. There has to be one GP, but we don't know if that's going to be group 1 or 2. It could potentially, we could throw a GP in group 3. That wouldn't break any rules. So let's hold off on that for now because we don't know which group that's going to happen in. But what about this third rule about Y? Y can never go with O. And so therefore, Y better go in one of these first two groups. And again, the GP could still either happen now in either group 2 or group 3. Either one is fine. We could potentially even throw an, I think that's pretty much the only thing that we have to worry about still is the GP. But since it could happen in more than one group, this is all we know for sure is what we have on the page. So let's take a look at the question, look at the answer choices. The complete combo of one of the windows must be what? And if you look through all the answer choices, there's only one of these that matches what we have on the page, and that's E. P, R, and Y. That is indeed group number 1 in our diagram over here, and so therefore the answer is E. And it can't be any of the others because none of the others match what we have on the page. So as you can see, this game really wasn't that bad if you work through it efficiently and you have a simple setup. You can see there really wasn't that much writing on the page. I know I crossed out a few things here and there, but it's pretty neat. It's pretty easy to look at and figure out. The trick is always being quick to look at the rules and to find the next inference. And that is to say that if you're playing with a certain letter, look at the rules that apply to that letter. So if you have a P on the page, look at the rules that have to do with P. And if you have a Y on the page, look at the rules that have to do with Y. And that's how you're always going to spot that next inference really quickly. So until next time, thanks for watching. If you liked the video, hit subscribe, and I'll see you in the next video.